Hello everyone and welcome back to our AWS Cloud Practitioner Essentials series. In this video we are going to explore one of the most important areas of cloud computing, cloud storage. More specifically, we will examine the three primary storage models available in AWS: block storage, object storage, and file storage. Although all three models store data, they organize and provide access to that data in very different way. Choosing the wrong storage model can lead to poor performance, unnecessary cost, or an application that is difficult to scale. To make this concept easier to understand, we will use a coffee shop as a practical analogy. A coffee shop must store many different things: coffee beans, financial records, marketing materials, employee documents, and perhaps even secret recipes. It would not make sense to store all these items in the same place or the same way. The same principle applies to data in AWS. By the end of this presentation, you should understand the differences between block, object, and file storage, recognize the main AWS services associated with each model, and how to select the correct services in common AWS. Now we're going to see the slide number 2 and we start with the coffee shop problem. Imagine that our coffee shop is becoming very successful. As the business grows, they produce more and more information. We now have inventory records, sales transactions, marketing files, employees manuals, customer information, and confidential recipes. However, these different types of information do not all have the same storage requirements. Let's start with inventory. Our inventory changes continuously. Every time we receive a new delivery of coffee beans, the quantity increases. Every time we prepare and sell coffee, the quantity decreases. This information must therefore be updated frequently and accurately. Next, we have sales transactions. Every transaction may include the date, the products purchased, the price, the pay method, and the customer information. These records must be stored securely, but they must also be searchable and available for reporting and analysis. The coffee shop also has marketing materials such as images, promotional videos, menus, and PDF brochures. These files normally do not change every second. They are usually created, stored, and later retrieved as completed file. Finally, we have secret recipes. These files may not require a special performance, but they definitely require strong security. One authorized people should be able to access them. This gives us the main idea of the slide. We should not place every type of data inside the one organized storage system. A good storage architecture considers four major factors: organization, access, performance, and protection. We must understand what the data is, how frequently it changes, who needs to access it, and how quickly it must be retrieved. Once we understand those requirements, we can choose the appropriate AWS storage service. Now we are going to slide 3, the three core cloud storage model. Three core cloud storage models. AWS provides three major cloud storage models: block storage, object storage, and file storage. Let's first look at the general differences. Block storage divides data into small pieces called blocks. The operating system sees block storage in a way that is similar to a physical hard drive or SSD installed inside a computer. Because individual blocks can be updated without rewriting the entire file, block storage is ideal for workloads that require frequent changes and low latency access. Typical examples include operating system volumes, business applications, traditional systems, and database. The main AWS block storage services discussed in the presentation are Amazon ABS and EC2 Instance Store. Object storage, in this case, object storage saves data as complete independent units called objects. An object contains the data itself, and a unique key and metadata describing the object. The object storage is ideal for images, videos, PDF documents, backups, archived logs, and other files that are normally stored and retrieved as complete items. The primary AWS object storage service is Amazon S3. File storage uses the traditional structure of files, folders, and subfolders. It is usually shared over a network, allowing multiple users or applications to access the same file. File storage is especially useful for content management systems, shared business documents like Linux file share and Windows file service. The primary AWS file storage services are Amazon EFS and Amazon FSx. A useful way to remember is this: block storage behaves like a disk, object storage behaves like a massive collection of individual files or objects. File storage behaves like a shared network folder. Now let's explore each model in more detail. We are going to the fourth slide. The slide 4, block storage fast updates low latency. Block storage can be compared to a virtual hard drive connected to a computer. In the AWS environment, that computer is often a Amazon EC2 instance. When data is stored on a block storage volume, it is divided into smaller blocks. Each block has its own address, allowing the system to locate and update a specific section of the data. Why is it important? Imagine that we have a very large database file and the need to update only one customer record. With the block storage, the system can update the specific blocks containing that record. It doesn't need to rewrite the entire database file. This makes block storage efficient for applications that perform frequent reads and writes. The term read means retrieving data from storage. The term write means adding or modifying data in storage. Another important term is latency. Latency is the time between sending a storage request and receiving the result. Low latency means that the storage system responds very quickly. Databases and transactional applications generally require low latency because even small delays can affect the performance of entire application. For example, imagine an online ordering system for our coffee shop. Every time a customer places an order, the application may need to verify the product inventory, create the order, record the payment, update the available quantity, produce a receipt. All these operations may generate multiple reads and writes within a very short period. Block storage is appropriate because it allows the application to update small parts of the data quickly and efficiently. The main idea to remember is that block storage is optimized for frequent updates, low latency, and disk-like access. Now we go to the slide 4th, AWS block storage services. AWS provides two important block storage options for EC2. EC2 Instance Store and Amazon Elastic Block Store, commonly called EBS. Although both provide block level storage, they have only extremely important difference. Persistence. Amazon EC2 Instance Store is physically storage attached directly to the server that hosts the EC2 instance. Because it is locally attached to the host, it can provide very high performance. However, instance store is not persistent or ephemeral. This means that the data should be considered temporary. Depending on what happens to the instance, such as termination or movement away from the underlying host, data stored may be lost. For this reason, instance store should not contain the only copy of important business information. It is better suited for data that can be recreated, such as caches, temporary files, processing buffers, scratch data, intermediate results. For example, suppose our coffee shop application generates daily sales reports. The original sales data may be stored safely in a database. An EC2 instance could use an instance store temporarily while calculating and formatting the report. After the report is completed, the final document could be saved in Amazon S3. If temporary data disappears, the report can simply be generated again. Amazon Elastic Block Store, Amazon EBS provides persistent block storage volumes for EC2 instances. Persistent means that the data can continue to exist independently of a running instance, depending on how the volume is configured and managed. ABS volumes can be encrypted, backed up through the snapshots, and modified to support changing capacity or performance requirements. A snapshot is a point-in-time backup of an EBS volume. You can use a snapshot to create a new volume and recover data after accidental deletion, corruption, and other operational problem. EBS is commonly used for example, EC2 boot volume, application file, database, persistent business data, workloads requiring consistent disk performance. The easiest rule to remember is instance store is temporary and fast. EBS is persistent and managed. When an exam question for describe temporary data that can be recreated, think about instance store. When the question describes persistent disk storage for an EC2 instance, think about Amazon EBS. Now we are going to the slide 6, object storage. Okay, Amazon S3 in this case as object storage. Scalable object storage, Amazon Simple Storage Service. Better known as Amazon S3 is AWS's primary object storage service. S3 is fully managed and designed to store and retrieve virtually any amount of data. Massive scale. There are many common use cases for S3. Static assets. S3 can store images, videos, PDF documents, downloadable files, and static website content. For example, our coffee shop website could store product photographs and digital menus in a S3 bucket. When the website needs an image, it requests the corresponding object. Backups and archives is also widely used for backups and long-term data retention. An organization can store copies of important files, application data reports, or database exports. AWS also provides different S3 storage classes designed for different access patterns. Frequently accessed data can use one storage class, while data that is rarely accessed for archived and for many years can use a lower cost storage class. For the cloud, in this case, for our exam practitioner, the key there is that S3 can support both active data and long-term archives, depending on the selected storage class and the configuration. Logs and data lakes. S3 is commonly used to store large quantities of logs and raw data. For example, an application may generate millions of log records. These records can be collected, organized into objects, and stored in S3 for later analysis. S3 can also form the foundation of data lake. A data lake is centralized repository that stores large amounts of raw, structured, semi-structured, and unstructured data. Analytics and machine learning services can later process this information. The essential S3 structure is bucket, object key, and metadata. The bucket is logical container. The object key identifies the item. The metadata provides descriptive information. Remember that S3 is not simply an unlimited network disk. It's an object storage service with its own access model and architecture. It is best suited for situations in which data is uploaded, stored, and retrieved as complete objects at very large scale. Now we go to the slide 8. File storage, shared file systems. The third major model is file storage. File storage is probably the most familiar model because it uses traditional folders, subfolders, file names, and paths. For example, an organization might have a structure such as company followed by training, manuals, internal documents, and uploads. The main advantage of file storage is shared access. Multiple users, servers, or applications can connect to the same file system over a network and access the same collection of files. Imagine that our coffee shop has 3 web servers running the same online ordering application. Customer can upload customized images for birthday cakes or promotional products. If each web server stores uploads only on its own local disk, the servers may have different files. A customer might upload a file through server number 1, but the next request could be sent to server number 2. Server number 2 would not have the uploaded file. A shared file system solves this problem. All 3 web servers can connect to the same file storage service and see the same files. File storage is also useful when migrating existing applications to AWS. Many traditional applications expect familiar file path and the network system protocol. Because managed file storage services support these patterns, the application may require few or no major code changes. This is sometimes called a lift and shift friendly approach because the existing application can often be moved without being completely redesigned. The central idea is use file storage when multiple systems need simultaneously access to the same hierarchical collection. I'm going to slide 9. AWS File Storage Services. AWS provides several managed file storage services. 2 important options are Amazon EFS and Amazon FSx. Amazon Elastic File System. Amazon EFS is a fully managed and scalable network file system, or NFS. NFS is a common file sharing protocol in Linux and Unix environments. EFS is especially useful when several Linux-based EC2 instances need access to the same files. Typical use cases are Linux web application, content management systems, shared application, files, container workloads, development environments, user home directories. Suppose our coffee shop application runs across 5 Linux EC2 instances. All 5 instances need access to the same training documents, uploaded files, and application resources. Instead of maintaining 5 separate copies, the instances can mount the same EFS file system. EFS can also be accessed from on-premises environments when the proper network connectivity, routing, and permission are configured. Amazon FSx, Amazon FX in this case is a family of fully managed file storage services for specific file system technologies. One example is FSx for Windows File Server. This service supports Windows-based file sharing and the SMB protocol. B protocol. It is useful for Windows applications, shared corporate folders, and environments that integrate with Microsoft technologies. Another example is FSX for Lustre. Lustre is a high-performance file system designed for workloads that process very large data sets. It is commonly associated with high performance of computing, specific simulation, machine learning, media processing, large-scale analytics. A third example is FSX for NetApp ONTAP. This service provides managed store with features and compatibility associated with the NetApp environments. It can help organization move existing enterprise workloads into AWS while maintaining familiar storage capabilities. The distinction to remember is use EFS primarily when you need a scalable shared NSFS file system, especially for Linux workloads, and use FSX when you require compatibility with a specific file system technology such as Windows, Lustre, NetApp, ONTAP. Now we're going to slide 10, additional AWS storage services. Additional AWS storage services. Not every AWS storage service fits perfectly into the categories of block, object, or file storage. Some services are designed to solve broader business problems, such as hybrid cloud integration and disaster recovery. AWS Storage Gateway is a hybrid cloud storage service. Hybrid cloud means combining on-premises infrastructure with the cloud services. Many organizations cannot move every application and every piece of data to the cloud immediately. They may have a legacy application, regulatory requirements, technical dependencies, or large existing data centers. Storage Gateway allows on-premises application to access AWS Cloud Storage through familiar storage interfaces. This helps the organization gradually integrate cloud storage without immediately redesigning every applications. For example, our coffee company might have a central office with an on-premises file server. Instead of purchasing more physical storage every year, it could use a storage gateway to connect the local environment with AWS storage. Depending on the gateway configuration, frequently accessed data may remain available locally, while the cloud provides scalable storage capacity. AWS Elastic Disaster Recovery, helps organization recover physical, virtual, and cloud-based servers into AWS after a serious disruption. A disruption could include hardware failure or a data center outage, a natural disaster, ransomware, a large-scale operational incident. The service continuously replicates data from the source server into AWS. During a disaster or recovery test, AWS can launch recovery instances based on that replicated data. Two important disaster recovery concepts are RPO and RTO. RPO, recovery point objective, describes how much recent data the business can afford to lose. RTO, recovery time objective, describes how quickly the system must return to the operation. The main point of this slide is that AWS storage is not only about saving files. It also supports hybrid cloud strategies, business continuity, and disaster recovery planning. Now we'll talk about, in the slide 11, shared responsibility for storage. shared responsibility for storage. AWS security follows the shared responsibility model. This means that AWS and the customer are both responsible for security, but they are responsible for different parts of the environment. AWS is responsible for the security of the cloud. This includes the physical data centers, physical servers, networking equipment, and the infrastructure supporting AWS services. The customer is responsible for security in the cloud. This normally includes the customer's data, identity and access permissions, resource policies, service configuration, backup choices, encryption choices, and key permissions, operating system and application when applicable. The exact division of the responsibility depends on how managed the service is. Fully managed services with a fully managed service, AWS operates nearly the entire underlying service infrastructure. The customer does not replace physical disks, maintain storage servers, or manage the internal architecture of the service. However, the customer is still responsible for deciding what data to store, who can access it, whether public access is appropriate, how long the data should be retained, which protection features should be configured. For example, AWS manages the S3 infrastructure, but the customer must configure the bucket policies and the permission correctly. Managed services with managed block storage, such as EBS, AWS manages the physical storage infrastructures and the underlying hardware. However, the customer remains responsible for snapshot, and the backup strategies, volume sizing, performance requirements, encryption, configuration, file system, capacity monitoring. AWS provides the capability, but the customer must design the appropriate solution. Unmanaged for or customer managed storage situation with a service such as EC2 Instance Store, the customer recognizes that the data is temporary. The customer is responsible for ensuring that important data is copied to persistent storage or can be recreated. The most important statement on this slide is in this case, AWS protects the cloud infrastructure, but you must configure and protect what you place inside the cloud. A managed service reduces operational work. It does not remove the customer's responsibility for data security and correct configuration. Let's move to slide 12, choosing the right AWS storage service. The slide provides a practical decision guide when choosing a storage service. Begin with the application requirement rather than beginning with the service name. Ask how does the application need to access the data. This like low latency storage for EC2 when an EC2 instance needs a persistent virtual disk. The typical answer is Amazon EBS. Think about operating system volumes, application storage, and database running on EC2. Temporary high performance local data when the application needs a very fast local storage, but the data is temporary can be recreated. Consider EC2 Instance Store. Remember that the instance store should not contain the only copy of critical information. Massive static files, backups, or media, when the requirement involves images, video, documents, backups, archives, log files, or data lake, consider Amazon S3. S3 is object storage, is designed for massive scalability, shared Linux file system, when several Linux servers require access to the same files through NFS, consider Amazon EFS. Windows Lustre or NetApp file systems. When the application requires a particular file system technology, consider the appropriate Amazon FSX option. For example, Windows SMB suggests FSX for Windows file server. High performance on computing may suggest FSX for Lustre. NetApp compatibility may suggest FSX for NetApp or ONTAP. In AWS exam questions, focus carefully in these keywords. Words such as persistent disk, temporary local storage, objects, shared Linux files, and Windows file server usually point directly toward a particular storage service. Key takeaways. Let's conclude by reviewing the most important concepts. We started with block storage. Block storage divides in data into blocks and behaves like a disk. It is appropriate for EC2 volumes, operating systems, databases, and applications that require frequent, low latency updates. Amazon EBS provides persistent block storage. EC2 Instance Store provides temporary local block storage. Object storage, in this case, object storage saves complete files and objects. Each object contains the data, a unique key, and metadata. Objects are stored inside the buckets. Amazon S3 is a primary AWS object store services and is commonly used for media, backups, archives, logs, documents, and data lakes. File storage uses the familiar hierarchical structure of folders and files. It allows multiple applications of users to share the same file system over a network. Amazon EFS provides scalable NFS storage, especially for Linux workloads. Amazon FSx provides managed file system for specific technologies, including Windows, Lustre, and NetApp ONTEP. Databases that are designed for structure or organize information that must be queried, updated, and analyzed continuously. Although database services will be covered separately, it is important not to confuse a database with the general purpose file or object storage. Shared responsibility. AWS manages the cloud infrastructure, but customers remain responsible for their data, permissions, access control, and service configuration. The more managed the service is, the less underlying structure the customer must operate. However, the customer allows responsibility for protecting and correctly configuring the data. Here is the final memory technique for AWS Cloud Practitioner exam. EBS means disk, S3 means objects, EFS and FSX means shared file. And always remember, begin with identify the data access pattern and then select the service. Thanks and thank you everybody for watching. In the next lesson, we continue exploring AWS services and examine how cloud database store, organize, query, analyze application data. Don't forget to review the difference. This is very important, the difference between block, object, and file storage before moving forward, because these concepts appear frequently in both real-world AWS architectures and certification exam questions. Thank you again, and see you soon.